Hello everybody, my name is Hello. Welcome back to the series where we're dealing with programming and design patterns in Python. Today we're going to be talking about the flyweight pattern. So the flyweight pattern is a design pattern which is designed to minimize memory usage by sharing common data or data between different objects, okay, than creating duplicates. What this means, let's say you're a game developer, okay, and as a developer you're going to be designing assets, right, and you're going to be developing in the code. Let's say you are developing a game, an adventure game, and there's a lot of trees in the background, right, and you have to create objects for these trees and place it there. The problem that you would have is, let's say you have tree A and then tree B. These two have the same exact features, right? And these trees, if you create one object for tree 1, one object for tree 2, in that case you're creating duplicates, right? And that will not be the best way to effectively use memory. So rather than creating two different objects, you're going to create the same object, and that's what we talk about, like saying sharing common data. So you'll create one tree object and you'll return the same object whenever this tree object is requested, okay. That is how that works. For example, in Angry Birds you have those piggies, right, and there'll be different size of piggies. There'll be 3 or 4 piggies, but if there are a lot the same piggy, there's so many piggies there. I'm saying piggies too much, I'm sorry, but you'll not create special objects for each of those piggies. Rather, you'll create one object and use the same instance, same object for all these other cases, which is what sharing common data means. Let us go ahead and see what this looks like. Maybe we'll take the same tree example, okay. So tree type, and this is a class that I'm going to be defining, and there's a lot of tree types that I use as a game asset, right? So I'm just going to go ahead and create an initialization for this. So let me just take maybe tree size and then tree color, okay. These two attributes are something that I'm going to take, and I'm going to do self dot size is equal to size and self dot color is equal to color, okay. Now the thing with this is, like, this is my tree type, and I say t1 is equal to tree type of small green tree, okay, and then t2 is also a small green tree. Now I go ahead and print t1 and I print t2. You can see that two different objects have been created. If you just want to see the address of it, you do id of t1 and then id of t2, okay. You can see that these are the addresses, memory addresses of this that's being created. These are two different objects that's being created. So our goal here would be to make sure that this in the top and this is the same object that's being reference, or the ID of that is same. How do you solve that? Well, it's very simple. So we could do with flyweight, and basically what we'll be adding is a factory. So we talked about factories already, right? So here it'll be kind of a factory but similar to that, okay. So tree type factory is what we'll call our class. So here we'll actually define a dictionary, okay. So that will be something like tree type. So tree type, okay, and this will be, maybe it's a private variable, so we'd want an underscore here if you want to. That's again up to you, but this is a dictionary. So the idea would be, right, so I will have, so maybe I can do this so that I can type some comments. I will have a dictionary with the following, okay. So the key would be a tuple of the size comma color, okay, and value will be the object itself, okay. So when I say this tree type object is there, right, so example entry would be for small comma green, I'm going to have it as this, something like that, and that's what we're going to be creating here, okay. So we'll go ahead and create a class method. We'd call it get define get tree type, okay. That's something that the user gets, okay. So the user will give the class this, and they'll give the size and the color, okay, and these are three things that we'll get from the user. Then what we'll do is we'll actually first of all check whether this size and color, this key is in the dictionary. So if so we size comma color, so we can actually define a variable before this. We'll say what our key is, so that we can just refer to the key. So key would be size comma color, right? So if key in tree type right? In that case, what can we do? This is tree type. Maybe I could do this as class dot tree type. Yeah, this would be correct, I think, because we're referring to the class variable, right? Yeah, that makes sense. So class dot tree type, if key is there, in that case, we'll actually go ahead and return this class dot tree type of our key, which is our object here, back to the user. Okay. Else, what will we do? We will just create this in the dictionary. So we'll do class dot tree type of key will be equal to our value. So this is tree type, right? So tree type of size comma color, and this is basically creating this object and then storing that here. Then we can return this back to the user. Now if you're looking at this, we're actually repeating this return statement twice, so we can add this comment. So something that we could add this better would probably be here. We can remove this one. So instead of me putting this as else, what I can do is I can do not in, and I could just go ahead and write this over here. So this is just saving space, and you could write this like this. This will be the optimal way to write that. But yeah, I mean, for the sake of understanding, I'm just going to write it like this so that you guys understand what's going on. Okay, so we are returning this, and that's it. So we're done with the flyweight pattern actually. So what I will do is I will go ahead and instantiate this tree type factory, and now what I will do is just like how I do here. Instead of this, I will just do this, but instead of this t1, so maybe this is t, okay, maybe tf would be there. So I will just do tf dot get tree type, and then I'll do small green, and then this is the same thing I'm going to be writing again. Now I'll just go ahead and print t1, I'll print t2, and then I can also print id of t1, and I'll print id of t2. Now what do you think will happen? At the code, you can see here it's the same id, correct? So this is the same memory address wherever this object is created. It's because that object is only created once. Now even if I go ahead and do another time and I print this value also, you are going to get the same object regardless of how many times I take this data. So rather than me instantiating an object every single time, I will instantiate the object once whenever somebody is requesting. So again, I'm not going through all these permutation and combination and storing it in the dictionary. No, when the user is asking if this exists in the dictionary, I will return that, else only then I will create this new value. So doing this saves a lot of memory, and we can reuse objects like this. So again, examples where this would apply something that we talked about before. I hope this very small pattern you guys were able to understand. If you guys have any doubts about this, please let them down in the comments so that I can take a shot at answering this to the best of my abilities. All of this code is in our GitHub repository, link below. Thank you so much for watching. If this video helped you, hit that like button. I'll see you in another video. Until then,